I can identify graphs that do and do not represent functions. So we're going to be able to look at graphs, and I'm going to teach you something today and tomorrow. You're going to be able to use a piece of information that you're going to be able to use to determine very easily if a graph is a function or not. It's a pretty important rule that is a pretty easy test for you guys to do with a graph. Then we're going to be able to use a graph of a function to calculate input or output given an input and input given an output. Okay, so I'm going to say she ran for 78, or she's 75 meters away from the starting line. How long did it take her to get there? You're going to use that graph and calculate some data points from that graph. Okay, so now let's take a look at slide number 4. Okay, slide number 4, you don't have this in your textbook. This is just a slide here. It says, what might this graph represent? What could be the story? So I want you to look at the label on these graphs here, these axes labels, these scale numbers, and I want you to, in that box down below, tell me, what could this graph represent? Hints, there's a lot of things it could represent. Friends that are in here, if you just want to think about it, we're going to talk about it in about 20 seconds. Somebody at home gave me a nice answer in the chat. Let's see what people are thinking. Ooh, Sawyer. Ooh, Sawyer is reading my mind. Okay. I'm going to give people another 10 seconds to look at these labels here and these values here. And I want you to think, what could this be representing? Okay, so Sawyer said he thinks it could be a plant or a tree. Olivia, what were you thinking?
I was thinking of plant.
Olivia was thinking of plant. Why were you thinking of plant? So Sawyer was thinking the same thing, but why would you think of plant as opposed to a tree?
Because I feel like a tree would take longer. So, because if you look at the rate of speed the graph is growing, the graph is like going up. It's like a tree, I feel like would take longer to grow than like, let's just say like a sunflower.
Okay. So we're looking at a plant. What about a plant? It's growth pattern, right? The growth pattern of a plant. So we're looking at a plant's growth pattern or growth. And, okay, I like it because we're talking about height in inches. Inches are small. And we're talking about number of months. Good. So we're looking at the plant, the growth of a plant. I have another question for you. Because of where it starts, do you think we're talking, Billy, go ahead.
I was gonna say that, but I was like, I don't really know.
Okay.
Normally, if you plant, like, let's say, like a tomato, like, you don't already have it pre-planted to move it.
Oh, okay. That was going to be my question. I was going to say, do you think this represents planting like a seed in the ground or going to the store and getting like a pre-planted, like a pre-grown plant?
It's 12.5 inches at 0 months.
So it starts at 12.5 inches, inches, right? So what does that tell us about the plant when he maybe got it?
That it was like already pre-grown and then he put it in the ground to grow more.
Good. So this graph could tell us, number one, that we're talking about a plant, right? A plant that's growing. But we want to be more specific because of where it starts. It starts at 12 centimeters, 12 and a half centimeters. So we're not going to be able to say, like, it grew from a seed because, like, that would be nutty cuckoo, right? That would be very confused. It's like one of those plants that you go to the store and you're like, I bought this fern. He is a fern. I'm going to plant him. And then, like, he grows from there. Or she. I'm not assuming that. So, awesome job. You guys, listen, you guys got that just as well as last period. Yeah. That's a high five, by the way. Very nice job, guys. Awesome job. So let's use this idea of a graph here. Now we're going to be matching some graphs to situations again. So if we look at slide number 5 here, I'm going to move my talkie box up here. We have 3 graphs here. Okay, we have A, B, and C. We need to match each one of these equations and descriptions to the graphs. Okay, so if we look at this first one here, if you're in your book, they're written as descriptions like A, B, C, right down here in number 1. So it says letter A says D is equal to 60t, where D is the distance in miles that you would travel in T hours if you drove at 60 miles per hour. One of these graphs represents that story. Second story here, Q equals 50 minus 0.4D, where Q is the number of quarters and D is the number of dimes in a pile of coins worth $12.50. Okay? And then lastly, we have A is equal to pi r squared, where A is the area in square centimeters of a circle with a radius r centimeters. So we need to match these 3 descriptions, A, B, and C, to the graphs up here. So if we look at these 3 graphs, Olivia, what are you thinking?
I think A goes to A.
A goes to A, okay.
And then graph B goes to C.
Okay.
And then graph C goes to B.
Okay. So let's focus in on this second one here. We're talking about this Q is equal to 50 minus 4.4D. You said that matched with which one of these graphs?
C.
C. Okay, and why do we think, this is the best one to start with, why do we think that this second scenario here, B, matches with C? Tiana.
Because the graph at the very top is starts with 50.
Good. And what does that match in our equation here? Avery? The quarters one. It starts with a y-intercept of 50. What else about this equation tells me that they match? Alyssa Button.
The line's going down for subtraction.
Very good. And the line is going down. It's a negative. And that correlates with this minus 0.4D. We have a negative slope there. Nice job. So now we're left with A and C. We need to match these two descriptions to a graph. So A, description A, this first one, says A is equal to 60t. Or D is equal to 60t, I'm sorry. So which one of these graphs did we think would go with this equation here? Do we have a, Tiana, what were you thinking?
For A?
You think graph A goes with description A?
Yeah.
Okay. Well, let's look at some of these numbers. What's my rate of change in this equation here? What's my rate of change or my slope, Olivia? 60. So that means after 1 hour, it needs to be equal to, oh goodness, I don't even have 60 on this graph here. So is that going to be a good match?
No.
Our graph has to have at 1 hour, it needs to hit 60. That's better represented with which graph?
B.
B. So this first description here is going to go with graph B. This second one is going to go with C. And because we have this r squared, is the reason we're going to have this sort of curved line here. Do you notice how that one's a little bit more curved?
Mm-hmm.
So when we square a variable, when we square a letter, that's going to give us a curved line like that. So C is going to match with graph A. Put it in the wrong spot. Sorry about that. Okay, so when we have a variable that's squared like that, an r squared, that means it's going to give us a more curved looking graph. Okay, now we matched them. What I want you to do on your booklets above each graph is we're going to write each equation. D is equal to 60t. Q Q is equal to 50 minus 0.4 D. And then A is equal to pi r squared. Okay? I'm just writing those above because we're going to be using those equations again, and I want us to remember which one goes with which one. I know it says it in the description below, but I just want it to be a little bit, so you don't have to go digging for it. Okay? Very nice job there, my friends. Let's take a look at slide number 6 if you're on your slides. Okay? In your textbooks, you're looking back at these graphs here. Number 2 tells us that we need to label each of the axes with the independent and dependent variables and the quantities they represent. So we just need to label these axes. So A is equal to pi r squared. D is equal to 60t. And Q is equal to 50 minus 0.4 D. Okay, so we have these equations here. We said our x-axis always represents our inputs or outputs?
Input.
Our inputs, very good. And if we look at that equation, which variable is our input? The variable we know. Billy?
R.
The R. And the R stands for our radius. Yes, Kaylee B. So we're going to label our x-axis radius with a label of what? Radius is given to us in inches, miles, centimeters. Look back at the description. It's written right in the description. Centimeters. Okay? And then our output is on our y-axis, what we're looking to calculate. What are we looking to calculate with this first one here? Yeah? The A, and the A represents our what, Billy?
Area.
The area, very good. So you're gonna write it in your book, right next to each one of these graphs. You're gonna write in radius and then area. And then what is our label for our centimeters gonna be? I mean, our area gonna be, I already said it. Centimeters, what? Squared. Yes, Tiana. Centimeters squared. Okay, you can, in your textbook, if you want to tilt it, like you can, but like I don't like to write tilted so you can see it. Okay, now we're going to do the next one together, and then the last one is the one where you're going to try it independently. What is our input on the second one here? B. What are we going to label that x-axis, Billy?
T.
T what? T represents our Alyssa.
The how many like miles? Oh wait. No, hours. How many hours?
Time, so it's hours or time in hours. Very good. And then our y-axis, our outputs is what? Brandon, what do you think? What's that D equal to if you look back at the description?
Distance.
The distance. Good. And our label for that is going to be? Oh my gosh, is it going to be inches?
No.
What's it going to be? Miles. Very good. Very good. Now, I want you to look at the last description. Knowing what we know about inputs and outputs, where they go on a graph, I want you to label your other two axes here. Try your best. Take 1 minute right now. Okay, looks good so far. And remember, you don't have to do them on the in the books if you don't want to. They're just here as like an option. You know, some people feel better on the computers. Okay, let's take 3 more seconds. Each Ethan, I'm gonna ask you, my friend. Okay, so when we're looking at our equation here and our description, which one of these variables do we know?
We know that, there's 4D.
0.4D, right? So the variable that we are going to be given is the D number of dimes. So which one of our axes here are we going to label number of dimes? The x-axis or the y-axis?
I think
Which one?
the X.
Very good, because what's happening is to this letter D, we're doing all these things to the number of D dimes. That's going to be our input. Tiana, what are you thinking?
Q equals quarters.
Q equals quarters, good. So let me just write this in here first. So it's going to be the number of dimes on our x-axis because that's the information that we know. And then the y-axis is going to be our, what is it going to be, Tiana?
Quarters.
The number of quarters. Very good, Tiana. Boom. I couldn't write sideways. I was going to try to write it sideways, but I can't. I have to like turn my whole body. Okay. Nice job, everybody. Fantastic. Okay, so this is where it's going to get a little bit funky because sometimes, so the one at home is going to be, so you're going to have this next slide. I will leave my friends at home, but it's going to look, it might look a little bit different. So let's take a look at this guy. Let's take a look at this. I'm going to leave this up for another second, and I'm going to look at the next slide together. We're going to be calculating some values here. We know our inputs. We're going to have to calculate some outputs for each one of these scenarios here. Okay, so it says, for each function, what is the output when the input is 1? Okay. So you have some space in your textbooks for this. If you want to do some work on this slide, we can here. So we have each of these equations. We said A is equal to pi r squared. D is equal to 60t and Q is equal to 50 minus 0.4D. Okay, so for each of these, we need to calculate our output when our input is 1. So if we look at this first one here, we're going to do the first one together. You're going to do the second two independently. Let's see what we have to do here. We know the input is 1. So we're going to have to plug 1 in for which variable? Which one of these variables in the first equation represents our input? Lily?
The R.
The R, very good. So we're going to take this equation. A is equal to pi r squared. And we're going to plug 1 in for R is what Lily said. So we can rewrite it as A is equal to pi times 1 squared. What's 1 squared? 1 times 1. So it's going to be A is equal to what? 1 times what? Times 3.14, or you could write it as pi. 1 times pi. Nice job. Very good. Okay. So now this next piece, someone is going to help me do this one. Actually, I want you to look at this next one. We know our input is 1. For B, I want you to calculate the D distance when our input is T1. Take 20 seconds right now to see if you can calculate what the output would be if you have an input of 1 for your T. D is equal to what? 60 times what? 1. So what's our output going to be? 60 what? 60, not T, because we said T was equal to 1. So it's 60, what is our label going to be on that? Bananas, pencils, pickles? Tiana?
60 hours.
Nope. We said our time was equal to 1. So our output is going to have a label of what? We just did this on our graphs, Bridget.
60 miles.
60 miles. Very good. Very good. Now for Q. Who can help me rewrite after plugging 1 in for my input here? What would my equation look like? We're plugging 1 in for our input here. How would I rewrite the equation? Oh, this button.
Q equals 50 minus 0.4, and then in parentheses 1.
Times 1. Very good. So 50, Q is equal to 50 minus what? 0.4 times 1 is just going to get us 0.4. Who can use their calculator? My Q is going to be equal to what? Bridget?
49.6.
49.6. Very good. So you plug that input into your equation and you calculate, you do what you need to do here. First you multiply to get this 0.4. Then we subtract 50 minus the 0.4 to get 49.6 what? What would be my label?
Quarters.
Quarters. That's my best. That's the best I can do. It's kind of wonky, but it's okay. It works. Awesome job. Now, this is where the slideshow is going to differ from what you got. My slideshow is going to differ from what you guys have. There was a little bit of a mix-up. I don't know what happened. I guess I clicked the wrong one. I don't know. If you don't have this slide, if you don't have this slide in the slideshow, I just want you to follow along. People in school, you have space in your textbooks to do this. So let's take a look. Okay. So now we're going to do some more calculating. I'm going to give you some inputs, and you're going to use these equations to calculate the outputs again. This one we're going to look at when A has an input of 2 and 3. We're going to say another input of 2 and 3. This one an input of 40 and 80. Okay? So I want you to focus just on letter A. Calculate what would your output be when you have an input of 2. Calculate your output when you have an input of 3. If you finish early, you can look at B, but I'm going to give you a minute and a half right now just to focus on calculating your outputs using this equation when you have these two separate inputs. Do you guys understand what I'm asking you to do? Grab calculators if you need them. Actually, I would leave it as just pi. So like you could do like 2 pi, 9 pi, whatever pi. So you're calculating these two outputs when you have these an input of 2 and 3. And take another 30 seconds. You're doing great, everybody. Doing great. This first one is probably gonna be one of the more trickier ones. We're gonna take another 10 seconds for ourselves. Okay, so we started with this equation. A is equal to pi r squared. In this time, we have an input of 2. So how am I going to, I hate it. How am I going to rewrite this equation with an input now of 2? How am I going to rewrite it here? Alyssa Button.
A equals pi 2 squared.
2 squared, very good. And what is 2 squared equal to? Bridget?
4.
Very good, because it's 2 times 2. So this is going to be equal to 4. So we're going to say 4 what? Bridget?
4 pi.
4 pi is equal to what?
A.
A, very good. So my output is going to be 4. Actually, let me write this. 4, and then you can write just like the word pi here. P-I. Okay? Very good. Now let's take a look at our input of 3. How am I going to rewrite this equation with an input this time of 3? How am I going to rewrite it? Annie, what are you thinking? Our input is what number? What's the number that I'm telling you the input is? 3. So I'm going to plug 3 in for which letter in this equation is the variable? The R, yes. And that would look like A is equal to pi what? Kaylee?
Pi 3 squared.
3 squared, very good. Or 3 times 3. So I can rewrite this as our A is equal to what? What's 3 squared? 3 times 3, Alyssa Button?
9
9 what? 9 times? 9 pi. Very good, Kaylee. 9 times pi. So my input is 3. My output is going to be what? Tiana?
3. Oh, wait,
9 what?
9 pi.
9 pi. Very good, Tiana. Very good. My output is 9 pi. Or you can write just the word pi. Very nice. Awesome job, Lady Jean. Now, ooh, this guy's not too bad. Okay, now we're looking at this second equation here. We need to, now we have inputs of 2 and 3 again, but you're going to use this equation to calculate what my outputs are going to be. Take another minute and a half to calculate the outputs when you have these 2 separate inputs using this equation, and then start to look at the cue if you finish early. Oh, you are on today. I love it. Let's see. So let's start calculating some values here. We're down here. Oh, you're doing it here. Okay, perfect. Just make sure that you move on because this is the one we did before. Now we're on an input of 2 and 3. So you're going to use this bottom section down here to help you organize. Awesome job. Yes, nice job. Oh my God, scary good. Look at you. Oh my goodness, I love, she has a little notebook for her special calculations. I love it, Lily. Oh my goodness, very good. Nice job, Kaylee D. Make sure we're in where we need to be. Very good on that. Nice job. You can, that's a good way of making a little bit. Nice, you can look that. Nice job. Is a good one? Yes, girl. Good job, Billy. Okay, so here we go. It's a train kind of day. I don't know why it's a train kind of day, but it is. Let's take a look at this guy here. So the equation that we're using is D is equal to 60T. So if we have an input of 2, what's our equation going to look like when I plug my value in? What is equal to what, Tiana?
D equals
60 times 2. So I'm going to get a total distance or an output of how far? Kevin?
120.
120 miles. Yes, very good. 120 miles. Very good. I was going to say pickles or pencils. I literally ask the same thing every single time. Very good. Now we're going to use that same equation, but this time when I rewrite it with my input of 3, what's it going to look like, Ethan?
It would look like, it would be D equals 60 times 3.
3, yes. And then when I do that multiplication, Brandon, 60 times 3 gets me a total distance of how far? 100 and how many? 120.
20.
Do we agree?
Yeah.
6 times 3, 60 times 3
Oh, no.
is not 120. Bridget?
It's 180 miles.
180 miles. Yes, you were on the right track. Nice job, Brandon. 180 miles. 180. That says 1,180. 180 miles. Very, very good. Now, here comes the trickster one. Tiana, what are you thinking? Oh, she's ready. Wait. Let me write it. So we're going to be plugging these 2 inputs into that last equation. Tiana said we're going to write it as Q equals 50 minus 0.4D. So how would I rewrite it? Go ahead. Minus 0.4 times, which one? 40. Very good. So we plug 40 in for our D. When you do that calculation with a calculator, what are you going to get? Bridget, help me reread the whole thing. Wait 1 second. It's going to be Q is equal to?
I got 34 quarters.
Okay, so let's take it 1 step at a time. 50 minus 0.4 times 40 got us how much? 34? Let's see. Calculator.
Negative 16 is
I trust you.
50
Point-
minus
point-
60.
0.4 times 40 gets me. Wait. Clear. Go. 16. Yes, Alyssa Button. Very good. 0.4 times 40 gets me 16. So when you subtract 50 minus 16, we get how many total quarters, Bridget?
34 quarters.
34 quarters. Very good. I knew how you got there. I just wanted to take it 1 step back. Good. Does everyone see how we got there? The trickiest part with this is going to be typing it into your calculator correctly. Are you close enough? Can you see? You're not close enough?
I don't have my glasses.
Okay, so then why don't you, here, why don't you stand up? You'll be front row center of my dancing. Oh man, she thinks we're a treat.
For you.
Okay,
Sorry.
treat. We're gonna go right now. We're gonna do this last one. So we're gonna plug 80 in this time for our D. 0.4 times 80. I know Bridget got this for me.
Hold on. Yeah.
You got this, you got this. Take your time.
Negative 32.
32. So 50 minus 32 is going to get me how many quarters?
It's going to be 18 quarters.
18 quarters. 18 quarters. So an output of 18. Very good. 34. Mr. Man, you got this, kid. Okay, listen closely. There's a whole second activity we didn't get to. We have a flex day tomorrow. So let me tell you what you're doing. On the last slide here, there's LinkedIn a CFA. We're not doing it. Don't do it for homework. I am going to, listen, I'm going to post it tomorrow. Your homework for this evening is 15 minutes of Alex time. That's all you got. No other work because I'm going to push everything forward. You can turn this slideshow in. I'm going to re-push it out tomorrow. Bridget, question.
So on Alex, there's no like 60 minutes and there's no 5 topics this time.
So the reason that it's not showing you the time is that, so the time is in there. The reason it's not showing it to you is because you have to take a knowledge check. So once you get it out of the knowledge check, the time that you did in your knowledge check is going to go towards the 60 minutes. But like there's a glitch in the system where it's not showing you the time. So just push through that knowledge check and I'll give you a time check on tomorrow.
Okay.
How much time you have done, okay? Ollie, I believe I got you moved over from Miss Albert's class. So you should be good. I need everybody to grab their jackets. We're gonna head down for our math break. Friends in here, I'm gonna throw you in the waiting room.
It's hard. I'm gonna hurt myself in the process. Speak herself.
Okay, you guys can start to head down. Go ahead. Quiet in the hallway, please.
We don't do the whole